I have a mic here. Thanks. Yeah, hello. Thanks for coming. When Ruth mentioned that the talks are short, it reminded me of one of my first encounters with the Android culture. I'm usually used, when I started Gradle, I came more from the Java angle, and then when we had the cooperation with Google and we started on the Gradle-based Android build system, I started to present at Android conferences and Android user groups. And I never forget when I came to the London Android user group and I had my usually 60-minute talk, right? And they came, how long is your talk? 10 minutes? I said, you need 15 minutes? Usually we only present 10 minutes and then we discuss, right? I said, wow, this is a different kind of crowd, different energy, and I really like the Android events since then. Okay, so what's new with the Android build system and Gradle? I mean, I guess quite a few of you have heard about or have seen or have attended the Android Developer Summit with the news around Android performance improvements, Android Studio 2.0 preview, and I want to dive deeper into basically all the stuff that has been done and the stuff that you can expect over the next 2 to 6 to 12 months, right? That to continue basically the exciting improvements we have seen recently. So when we talk about Android developer tooling performance, I want to talk about the 3 most important scenarios. So first, debugging in Android Studio, right? Second is a pre-commit build you do from the command line, right, to figure out, is my code good to commit? And the third one is CI builds, right? And those are, when you talk about performance, those scenarios are influenced by different aspects of the Android tooling performance, right? So before I show you the first numbers, the sample app that I'm using for almost all the numbers in this presentation are from building the Google I/O Android app. It's a pretty cool app in terms of for this performance testing. First of all, it's open source and hosted at GitHub. It's a really juicy app, so it gives you some real numbers. So if you want to do your own experiments, check this out. So let's start with the number 1 scenario, the most important scenario, the most frequent cycle for Android developers, debugging or manually testing in Android Studio. So the experiment I'm going to show is an app that is already imported into Android Studio, the Google I/O app. And it has already been once deployed to a virtual device. And now we're adding 1 line of code and redeploy. Right. So let's see how long it takes with version 1.4 of Android Studio, as well as the current production version of the Gradle Android plugin. Well, not almost current production version. There's no Android Studio 1.5 and Gradle plugin 1.5, but the story hasn't changed, right? We're using the latest and greatest Gradle version 2.9. So we go into the source code, right? Just add 1 line of code. Push the deploy button, and now we're waiting. Gradle is running, then we have to pick the device, and then the install process starts. So just the Gradle stuff took 9 seconds, and yeah, we can have 1 cup of coffee or a glass of wine. And hey, here we go. So it took 27 seconds, right? And I guess most of you know that experience, right? How that is. And in 1.5, they made some improvements, but nothing that with certain scenarios help, but nothing that makes this dramatically faster, right? So now we're looking at Android Studio 2.0 preview and the Gradle plugin 2.0 alpha 1. Again, Gradle version 2.9. So we add 1 line of code to the code base and push deploy. And here we go, 3 seconds, right? So this is this will change the life basically of every Android developer, right? Seriously, it is a revolution for the Android developer tooling experience. And so one thing you can already see here, that the Gradle build itself has been much faster, right? That is one thing, and then the deployment was much faster, right? So what is happening under the hood? Why is this so fast, right? So it's called the instant run feature, and so the most important aspect of that is when you change your source code, the app is neither reinstalled nor restarted, right? So the changed parts of the codes overwrite the existing one. So they send the changed code to the app, right? And they don't even reload, right? They basically overwrite the changed parts, and Google calls this a hot swap, but without class reloading, as said, and that dramatically accelerates the deploy part of the process, which is the most time-consuming part. Additionally, Android Studio uses special Gradle tasks and Gradle configuration to short-circuit certain checks Gradle does when you run the build from the command line, right? Because Android Studio knows, for example, what has changed, right? So Gradle doesn't need to check again every source directory for changed files. That is the reason why Instant Run only works from Android Studio, right? Not from the command line. It is important to understand that not all changes can be applied that way. So the Google Android team will enhance the type of changes that can be applied. But obviously, changes like changing the app icon, right, can't be applied that way. But also structural changes to the code, right? Deep structural changes can't be applied that way. The good thing is Android Studio knows when it can use Instant Run and when it has to do a full deploy. So you don't need to think, oh, is that a change where I can use Instant Run for? You just say deploy, and then Android Studio will decide for you. So this is already super exciting, but there is more good news, right? That was the Android Studio debugging lifecycle. So let's look at the next very important scenario, a pre-commit build that you execute locally to make sure your changes are good to be pushed, right? You can execute it from the command line or from Android Studio via the Gradle view, right, the task view. So I use a simple metric to get a performance baseline for that kind of pre-commit build, right? So I get the baseline from executing the install debug command, right? Usually when you do a pre-commit build, you run tests, right? And the biggest part of running the test in terms of for the performance baseline is installing the app, right? So just running install debug gives you a good baseline for the typical pre-commit build, right? Compiles everything, packages everything, and installs. So in blue, you have the build time for the current Gradle Android plugin when you add one line of code to the Google I/O app, right? So what you can see is the build time is dominated by Dexing and install, right? The overall build time is 17 seconds, and almost 14 seconds is Dexing and install, right? With the 2.0 alpha version of the Gradle Android plugin, Dexing gets dramatically faster, right? So that is something you have already if you use 2.0 alpha plugin. And that has a strong effect on the overall build time, right? 3-4 seconds less. What you still suffer from is the slow install time, right? That is still, so I just had a chat with Sasha about that, right? So to address this, the Google Android team has announced 2 other very cool features that will be available soon, right? So first is cold swap. So with a cold swap, you don't need to reinstall your application. You just replace the bytecode and restart, right? So it's not a hot deploy where you don't restart the app, right? You change the bytecode for a running app. With a cold swap, you just save the full install phase of the application. But when the code has changed, you pull in the new code and you restart the app, which is not as fast as hot swap, but still dramatically faster than a full install. So this will accelerate the deployment in Android Studio, for example, also for every change that does not qualify for instant run. It will also be able to be used from the command line, making your pre-commit builds much faster. So the other exciting feature is Emulator 2.0, right? A much faster emulator. And not for those who were at the Android Dev Summit, they know those numbers. So what the Google Android team did, they took the biggest APK in the Play Store, right, 45 megabyte, and deploying this, installing this with Emulator 1.0, right, takes almost 300 seconds. Deploying this app to a Nexus 6 phone is still almost 150 seconds. And with the Emulator 2.0 that will be released in the next month, this goes down to less than 40 seconds. So even when you can't use instant run, right, because you're running from the command line, or it's the first time you install your app, or you have a change that doesn't apply for instant run, the cold swap and the much faster emulator will dramatically accelerate your cycles, right? And those are now estimates, right? It's speculative, but there are some other technologies that use similar tricks with Android, so I think the numbers will be rather better than the estimates than worse, right? So I expect that Emulator 2.0 will cut the install time by 2, right? So which has a strong effect on your overall build time. And I expect the cold swap to cut it basically by 75%, right? So, and then it gets really interesting. A pre-commit build gets down from 17 seconds to 7 seconds, right? So, and there is something deeper here, right? It basically changes the whole game we're now in and how we can move forward. The build time is no longer dominated by dexing and installing, so which means smaller absolute improvements are now becoming much more relevant and have a much stronger impact, right? Now it becomes interesting to get 500 milliseconds there and 300 milliseconds there, right? When everything was dominated by dexing and installation, it was not so inviting to do that, basically, right? So in general, Gradle performance over the last year has already improved significantly, right? We release about every month, and I want to show you an example. So between using Gradle 2.1 and Gradle 2.9, right? Of course, dexing and installing, Gradle has nothing to do with it. It just delegates to the Android tooling. That hasn't improved, but if you look at all the other activities, the time got down from 5.5 seconds to 3.6 seconds. And so without the improvements in Gradle, it would be 11% slower, right? And now with all the dexing and installing improvements, without improvements, Gradle would be 30% slower. So it's a high motivation now for us to make that thing as fast as we can make it. So it's also interesting to see how Gradle has changed when you do a no-op build, right? So you have an Android app, you run the Gradle build when nothing has changed. With Gradle 2.1, that took 2.5 seconds. With Gradle 2.9, that is now down to 1 second. If you execute that from Android Studio Gradle Runner, the numbers are even better. With 2.1, it's 1.9. With Gradle 2.9, it's 0.4, right? The reason why the numbers are better when you run Gradle from Android Studio, when you run Gradle from the command line, even if you're using the daemon, we always fire up a client JVM, right? That has some 500-600 milliseconds startup time, right? At one point, we will have native clients in Gradle that you don't pay that price anymore, but in any case, exciting improvements, right? So the last scenario I want to talk about are CI builds, which usually means you do a clean build, right? So now we're doing a clean install debug build. Install debug basically representing again that you will run some tests that need to be installed to a device. And if you now look at the numbers when you do a clean build, dexing is killing you, right? 25 seconds, right? 3 times longer than the install. So why is that? Anyone has an idea? You always fall asleep when that happened. Then you had no time to think about it, right? So the Google I/O app has quite a few dependencies, right? And what what you need to do when you build this application, all those dependencies need to be dexed. And at the moment, Google puts the dex dependency in the build output directory. So when you run the build again, you don't need to dex your libraries again, only the changes in your code, right? But when you do a clean, this basically cached pre-dex libraries gets removed, right? And that is why you not just now have to dex your code, but also have to dex all the libraries, right, of the Google I/O apps. And that took a long time with Gradle Android plugin 1.3.1. So with the 2.0 plugin, you still have to dex everything, but it's now down to 5 seconds because dexing got so much faster, right? So that is, for clean builds, that's a dramatic improvement, right? It is less painful, but we will improve this further, right? So how do we do that? We will start, beginning of the year, we will start working on a Gradle long-term cache for all of Gradle build output, right? So a long-term cache that is safe and reliable, right? And the output or the build output in that long-term cache will survive any clean operation, right? So the predex libraries would no longer live in the build directory of Gradle, but in this long-term cache, right? So it has to be a smart cache. It has to be reliable, right? So, for example, if you change the version of your build tools, of your dexing tools, right, then we shouldn't get anything out of the long-term cache, right? Then we should know, oh, hold on, that's a different tool chain that has produced that output, so let's redex, right? So we have to make it super reliable because it's long-term, right? So, but we will solve that, and then you will see something like this, right? Then we don't need to ever basically redex the libraries of the Google I/O app. We only need to redex the code. And that will get the build time down again to 1.3 seconds from what you have seen at the beginning when you were not doing a clean build, right? So that is, yeah. So and with all the other improvements we expect, right? That is very, very significant for CI scenarios. And we have now talked with a few clients that saying with all the incrementalness, right? The developer build is now performing very well, and now the CI build is the biggest pain point. That the CI builds take so long. So this is going to be addressed, amongst other things, with the long-term cache, right? Which will eventually also be distributed, right? So that CI can pump in stuff into the long-term cache, so you, as a developer, basically then never have to predex anything because it is already available in the long-term cache. So there's more to come. Something that will come pretty soon is enabling incremental compile for incremental Java compile for Android. At the moment, so Gradle offers an incremental compile option developed by this guy over there, Stefan Faber, if you remember. And but for some reason it can't be integrated with the Google Android plugin yet. That will change very soon. And look at some numbers. So when you have Java compile time, when you have 500 classes, right, it takes that have 20 lines of code, which is very short classes. It takes 300 milliseconds to compile when you add one line of code. Without incremental compile, with incremental compile, it's 60 milliseconds. When you have 5,000 classes with 20 lines of code, it's 3 seconds versus 300 milliseconds. So it's an order of magnitude. And we talked with quite a few organizations that have larger Android apps, right? And they said, our Java compile time is 20 to 30 seconds, right? For them, that is killer, right? So we can't wait to see that being available to you, right? And an important thing to keep in mind. So even if the improvements like are 300 milliseconds, you don't care about that much when it's on CI. But when you're using instant run, right? It's all about the more instant, the better, right? The more you will remain in the flow, and every 100 milliseconds will count, right? And the goal is, as I see it, I mean that when you're in Android Studio, with every save, right, you can immediately see the update, right? At the moment, instant run is fast. It's a couple of seconds, right? But we are more ambitious than that, right? So I hope next year we might have another order of magnitude of performance improvements. And yeah, so good stuff. Yeah, talked about the distributed cache. One thing to keep in mind, the dexing time has been improved without adding incremental dexing, right? So the key reasons why dexing is so much faster is one reason is that you can now dex in memory, which has a strong effect. And the other thing is that the dex merging, when you have pre-dex libraries, the merging algorithm is now much faster, right? So, but when you change a single line of code, right, you will soon have incremental compile, but still everything will be dexed, which is now pretty fast, but it can even be faster when the dexing is happening incremental, right? And that is not on our plate, right? From what I understand, the Google Android platform team is working on a new dexing compiler called Jack. It has one thing it does, it consolidates the source code compilation and the dexing in one step. It has already an incremental dexing option, so check out the article below if you want to learn more about that. So for medium to small projects, the Gradle overhead in terms of how long it takes with the build to start if you're using the daemon is very fast now, right? I mean, we will continue to improve it, but for medium to small project, it's no longer an issue, right? But Gradle is also used for very large projects, including some very large Android projects, and to scale basically also for the very large projects, we are working on a new configuration model, and that has a new component model that has much more smartness in making Gradle configuration super fast, even if you have massive builds. Right? So this new model is already used by the experimental Android plugin. So if you look at the link below, if you want to play with that, it's the new experimental Android plugin, which means it's not 2.0 alpha, it's even more alpha than that. It comes with the better, faster configuration model of Gradle, and it also uses the Gradle native plugins for the NDK support. Right. So yeah, finally, with the new model, we can reach a state that we know everything is now immutable, and we can reliably offer parallel task execution. That will also come next year, especially for Android that has many tasks because of the variants, right? That will be very nice to have. So the performance improvements that we have or will have in the next months that are dramatic, and there's much more to come over the next month and during the rest of 2016. It is important to understand, I think the Android Studio toolchain is great, right? And it will be hard to find another toolchain with similar complexity that is so fast, but at the same time deeply extendable, declarative, polyglot, scalable, with fantastic dependency management, deep IDE integration, right? There are other platforms where those are conflicting requirements, right? They're just focusing on performance, and that's a pretty easy task to solve if it's just about performance. But if you try to get all those qualities into a toolchain, that's a real achievement, yeah, I think it's an amazing platform that is pioneering basically developer tooling. That's how I see it. And with performance being solved, right, I can't wait to talk next year about other areas we're working on. The new NDK support is super exciting. The variant-aware dependency management, where we understand, okay, that is the debug variant of a dependency, that is a release type of a dependency, first-class microservice support, that's all stuff we will be working on for Gradle. Yeah, Ruth talked already about the pre-beta of our SaaS offering. Check it out at gradle.com. Talked about the Udacity class, so thank you very much.